Hello everyone, my name is Bryce Kelley, and today I'll be discussing about a comprehensive guide on Inter-VLAN routing, alongside a guide on performing a router on a stick Inter-VLAN routing configuration, with an additional tutorial through using Packet Tracer. Overview of Inter-VLAN routing for a router on a stick configuration. In this video, I'll delve onto the concept of Inter-VLAN routing based on the process of how the configuration works and how Inter-VLAN routing can be implemented through VLAN communication. I'll then discuss about the usage of forwarding traffic through the process of Inter-VLAN routing. Afterwards, I'll then discuss about what the three different methods are in using Inter-VLAN routing. Once I finish up on the three methods, I'll then discuss on potential solutions towards common issues in Inter-VLAN routing via troubleshooting and verification. Inter-VLAN routing will be discussed throughout the topic of preventing malicious traffic, the use of network performance, and both broadcast and routing traffic between various VLANs and Inter-VLAN routing. What is Inter-VLAN routing? Well, to start, Inter-VLAN routing is the process of forwarding networking traffic from one VLAN to another VLAN. What can Inter-VLAN routing do as a configuration? Well, Inter-VLAN routing is used to enable communication between various devices that are residing in different VLANs. But, in one instance, let's just say a company that can use Inter-VLAN routing as a configuration by segmenting a network into VLANs from the company's larger network. They could divide it into smaller and more convenient networks to support the company's network traffic. You can use a router to communicate or route traffic between the different networks, but in terms of Inter-VLAN routing, the configuration can be used via the router to have at least one interface that belongs to each VLAN to communicate with other VLANs. Once the device on one VLAN is sending traffic to another VLAN, the traffic is sent to the router, which the router starts to decapsulate the traffic so the VLAN's destination can be determined. And then, the device encapsulates the traffic for the destination VLAN. Thus, the router now will send the traffic towards the destination VLAN. Understanding the process of Inter-VLAN routing configuration. Basically, the process of Inter-VLAN routing configuration can involve the following steps. The first one is VLAN creation, where the VLAN can be defined and assigned to a network device or network devices via the switch, and you must have a unique ID set for each of the VLANs. Second, you must configure the switch port configuration after creating the switch ports in the VLANs, where you then need to configure the switch ports to belong towards appropriate VLANs that were created inside the switch's configuration interface. Third, you now need to configure the router to route between the VLANs. You'll then configure the router to have the interfaces assigned for each VLAN to communicate with other VLANs. Fourth, you need to verify that the configuration is working properly, so you must use a variety of different techniques and tools such as pinging between each VLAN. Once everything is configured correctly, you may need to do some troubleshooting using different tools and possible solutions towards issues of your Inter-VLAN routing configuration process. The process of forwarding traffic. What is the forwarding traffic process? There are three steps involved within forwarding traffic. The first one is known as decapsulation, whereas the router removes the header information from within the packet, such as the VLAN ID. Secondly, the routing step will involve the router to determine the destination VLAN for the specific packets via the destination IP address that is being provided onto the network. Thirdly, the encapsulation for the router to add the header information will be for the destination VLAN towards the packet. After the packet is encapsulated, the router will start to send it towards the destination VLAN. 3 different inter-VLAN routing methods. The 3 methods used in inter-VLAN routing are the following: router on a stick, legacy inter-VLAN routing, and layer 3 switch. The first method, known as the router on a stick, is one of the most common and straightforward ways of implementing inter-VLAN routing. It involves using a physical single router interface to connect to multiple different VLANs. The interface is configured then as a trunk port, which allows it to carry traffic from all of the connected VLANs. The router will then forward traffic between the VLANs based on the VLAN IDs of the incoming and outgoing packets. The next method would be legacy inter-VLAN routing, which is a traditional method for enabling communication between the VLANs. It involves using a router within multiple physical interfaces that are each connected to a different VLAN. The router acts as a bridge between the VLANs and forwards traffic between them based on VLAN IDs. Now, for a third method, will be a layer 3 switch, which is a device that can route traffic between VLANs at the network layer, at layer 3 of the OSI model. This means that layer 3 switches can not only forward traffic based on VLAN IDs, but they can also consider other factors such as IP addresses and routing tables. This makes layer 3 switches a more powerful and versatile solution for inter-VLAN routing. Then, using a router on a stick or VLAN trunking, such as legacy inter-VLAN routing. Verification and troubleshooting in inter-VLAN routing. Common issues that can be resolved for inter-VLAN routing can be the following: ping failures between the VLANs, broadcast traffic flooding the network, and even packet loss between the devices and on different VLANs. To fix the common issue of ping failure, for instance, you can troubleshoot the VLAN configuration to check if the devices are assigned to the correct VLANs, and that the VLANs are properly configured on the switches. You can then check trunking configuration in order to ensure that the trunk ports connecting the switches are configured correctly and that the same trunking protocol is being used on both ends. We can verify our routing table to check if the router's routing table has entries for the subnets of the VLANs involved. Then we could test with different devices, use different devices or workstations to eliminate device-specific issues. Once again, now you can verify the ping from router to devices on both VLANs to verify such connectivity. You can use traceroute even to perform traceroute between devices on different VLANs to identify any routing issues along the path. You can then sniff network traffic. Capture network traffic using a network analyzer to observe inter-VLAN communication. The next common issue is the broadcast traffic flooding the network. Okay, so now what we can do here is verify the VLAN isolation. We can check, for instance, that the VLANs are properly isolated, preventing broadcast traffic from leaking between them. Between access control lists, we can verify if ACLs are properly configured to block any unnecessary broadcasting traffic. We could disable MAC address flood protection. Disabling MAC address flood protection on the switches can help us to see if there is a cause in excessive flooding. We can upgrade switch firmware to ensure the switches are running the latest firmware to address any potential software bugs. Now you can verify the broadcast traffic to analyze network traffic to observe the level of broadcasting traffic flow and identify any sources of flooding between the network. We can use different devices to generate broadcast traffic and observe how it propagates through the network. And confirm that access control lists are effectively blocking broadcast traffic by testing with different traffic patterns. And the last well-known common issue we'll discuss here now is packet loss between devices on different VLANs. We can check for routing loops. Verify that there are no routing loops that are causing traffic to loop endlessly. You can analyze the network path between devices on different VLANs to identify any potential bottlenecks or congestion points. We could then check for hardware issues by inspecting our cables, ports, our switches, and for physical damage or malfunction of each one. We can optimize router configuration by we can tune router settings, such as queuing and buffering, to improve performance with the router. You can then verify by using network testing tools to measure latency and packet loss between different devices on different VLANs. We can analyze network traffic patterns to identify any congestion or packet drops, and then simulate network traffic under load to assess performance under stress conditions. The prevention of malicious traffic on inter-VLAN routing. How can someone prevent malicious traffic on inter-VLAN routing? Basically, someone can prevent malicious traffic by using various strategies and approaches towards the problem of malicious traffic, such as, let's just say, utilizing access control lists or even network segmentations upon using a network. And many are ways to approach malicious traffic via inter-VLAN routing. Such strategies that can be used to prevent malicious traffic can be the use of, once again, access control lists, network segmentation, intrusion detection systems, and even the analysis of network traffic. The first strategy, one that can use, is access control lists, where the ACLs can help someone permit or deny such types of traffic based on its rules that are being in effect. Someone can use access control lists towards their routers and switches to block potential malicious traffic from entering or causing widespread issues onto the VLANs within the network. The second strategy to use is network segmentation, where someone can divide up their network into smaller and lessly large base networks to have manageable VLANs. This approach to network segmentation can help limit damages caused by malicious traffic in such events of potential security breaches. Thus, malicious traffic can be stuck to a specific VLAN and cannot easily spread to other parts of the person's network. Another strategy that one can use is the use of intrusion detection systems, where someone can deploy the intrusion detection system to look over their own network traffic and find any malicious activity. By using an intrusion detection system, we can help someone block attacks in real time and to protect themselves from the network from intrusion attempts. One of the most important yet primary strategies to use in analyzing is called analyzing network traffic, where someone can just normally look at the network traffic on a regular basis to look for potential anomalies or potential patterns that might show a sign of malicious activity. And just simply analyzing network traffic as a strategy can help prevent malicious traffic on someone's network when performing inter-VLAN routing, so security measures can be met before further damage onto the network. Network performance in inter-VLAN routing. How can network performance be used in inter-VLAN routing? Well, let's just say network performance in inter-VLAN routing can simply be used to improve the optimization of the network path. Even use load balancing, prioritizing traffic, using high-performance hardware, segmentation of the network, and even just monitoring the overall network performance itself. Why is network performance important in terms of inter-VLAN routing? Network performance is important in inter-VLAN routing because of its optimization and efficiency towards the transfer of data between devices on different VLANs. You must optimize the network path that needs to be set to each VLAN in order for each proper network performance towards networking traffic to be valid. Broadcast and routing traffic between the various VLANs and inter-VLAN routing. What is broadcast and routing traffic? Broadcasting traffic is a type of data transmission that can send a packet to all the devices within a specific given network segment throughout each different VLAN. Every device in the network will receive such of a same copy of the broadcast packet, despite if the packet, wants to receive it or not, they will still receive the broadcast packet through broadcasting traffic. Routing traffic, on the other hand, is basically a more targeted type of data transmission that instead of sending a packet to every single device in the network, like broadcasting traffic, the use of routing traffic is basically the direction of directing the packets to the specific device that needs it. This is achieved simply by the encapsulation of the packet within the destination device's IP address. How can both types of traffic be used between different VLANs and inter-VLAN routing? Broadcasting traffic can typically remain within an original VLAN due to the instance of the use of VLAN segmentation. However, there are situations where broadcasting traffic does need to cross VLAN boundaries. This is often necessary for network discovery protocols, such as ARP, to operate across the entire network. On the other hand, routing traffic is the primary method for communication between devices on different VLANs. When a device can send data to a device on another VLAN, let's just say the traffic will be encapsulated within the destination VLAN ID. The router will then decapsulate the traffic and route it to the destination's VLAN based upon its IP address. Router on a stick, inter-VLAN routing. As you may see here on this image that is shown, this is a screenshot that I have made from my topology that I've created for my router on a stick packet tracer that will be explained after this whole presentation. And now, for part 2 of our overview for inter-VLAN routing and a router on a stick configuration. Throughout the rest of the presentation aspect of this video, I will be discussing about what a router on a stick configuration is, and the uses of implementing it for inter-VLAN routing. I will then discuss on the importance of configuring access and trunk ports for a router on a stick configuration. After that, I will further discuss VLAN and trunk configuration for a router and a switch. Then I'll talk about the sub-interface configurations for the router, and I'll discuss on common issues that could be resolved via troubleshooting and verification for a router on a stick configuration. Router on a stick configuration. What is a router on a stick configuration? Simply known as one of the inter-VLAN routing methods, a router on a stick configuration is a method for enabling inter-VLAN routing that uses a single physical router interface to connect to multiple VLANs. How can someone implement a router on a stick configuration for their network? Such configuration steps that can be used are the following. The creation of VLANs. We can define the VLANs in the router and switch to be used for inter-VLAN routing, such as router on a stick configuration. Second, we can configure the trunk ports and protocols, where you can start by identifying each switch port that will be connected towards the router, and then by configuring them as trunk ports, and then enabling the protocol, or whatever protocol that's used that is best appropriate towards the trunking protocol, such as the IEEE 802.1q standard on both the switch and router. Then what we need to do is to create the sub-interfaces as our third step onto the router by configuring each VLAN that the router connects to. So we can create a sub-interface on the router's physical interface. Once we create the sub-interfaces, our fourth step is to then assign the IP addresses and subnet masks to each sub-interface, where we can correctly configure each of the sub-interfaces' corresponding VLANs. Finally, as our last step, our fifth step here, we can configure the routing table, where we can add data entries towards the routing table to direct the network traffic between those different VLANs. Importance of access and trunk ports. What are both access and trunk ports? Trunk ports, which can also be known as hybrid ports, serve as the connection points between switches or between a switch and a router. Access ports can provide the connectivity for end devices, and they are designed to connect individual devices, such as computers, printers, or access points, to a specific VLAN. Why are both types of ports important for a router on a stick configuration? Well, the importance of access ports are that the access ports can enforce VLAN isolation, they can prevent broadcast traffic from flooding the entire network, and enhance security measures. Once again, access ports can provide connectivity for end devices that allow them to access network resources within their respective VLANs. The importance of trunk ports are to enable communication between the devices on the different VLANs, thus facilitating data exchange and collaboration. Trunk ports can handle VLAN tagged traffic to ensure that the data is routed onto the correct destination VLAN to optimize network efficiency. VLAN trunk configuration for the router and switch. How could someone perform VLAN and trunking configuration on their switch and router when doing a router and a stick configuration? Configuring VLANs and trunking on a switch and router for a router and a stick configuration can involve the creation of the VLANs, designating trunk ports, and enabling trunking protocols. As you may see here on these pictures that are shown of this more screenshots I have from the packet tracer, I have displayed what would be shown after the configuration of the VLANs and trunking for my router and a stick configuration. Sub-interface configuration for the router. How could someone perform configuration on the router for the sub-interfaces? Configuring sub-interfaces on the router for a router and a stick configuration can involve creating the sub-interfaces for each VLAN that the router will connect to and assign the IP addresses and subnet masks to each of the sub-interfaces. As you can see here, once again, more screenshots of what I have from my packet tracer for the router and a stick that I created. You can see how I have verified my configuration of each sub-interface on my router for the router and a stick. Once again. Troubleshooting and verification towards common issues in router and stick configuration. Common issues that can be resolved are the following: ping connection failure, VLAN misconfigurations, trunking issues, and the use of verification on each common issue that is listed on the slide, such as these ones here: trunking, VLAN, and ping. First one we'll discuss about is ping connectivity failures. We can verify that the VLAN configuration on both the router and the switch are working correctly. We can check trunking configuration for compatibility between the devices. We can validate routing table entries for the connected VLANs. We can test with different devices to eliminate device-specific issues. The next issue would be our VLAN misconfigurations. We can double-check VLAN IDs and assignments on both the router and the switch. We can ensure devices are connected to the correct switch ports and VLANs. We can verify VLAN tagging on the switch and router interfaces, and utilize VLAN management tools to monitor VLAN status and configurations. The next issue would be trunking issues, such as to what we can confirm that trunking is enabled in both the router and switch interfaces. Now we can verify that the same trunking protocol is configured on both devices once we check for compatible trunking encapsulation, such as a protocol just as the IEEE, let's just say, 802.1q standard for trunking. And once again, we can utilize network diagnostic tools, but this time we can analyze trunking traffic and identify potential issues. Once troubleshooting these common issues on a router and a stick, you can start to verify each issue. We can ping between devices and different VLANs from the router. Use the ping command to test connectivity between devices and different VLANs. And we can verify that ping requests are successfully transmitted and received between those VLANs. We can perform traceroute to identify routing paths between VLANs. Once again, we can use traceroute, like I mentioned earlier in the presentation, to provide the path data packets that are being taken between the two devices. And then we can analyze traceroute results to ensure traffic is routed throughout the expected paths. We can analyze network traffic patterns and observe inter-VLAN communication by monitoring network traffic patterns using network management tools and verifying that traffic is flowing between VLANs as intended. Last but not least, we can utilize VLAN management tools to monitor VLAN status and configurations. VLAN management tools can help us verify by providing visibility into VLAN status and configurations. And we can monitor VLAN activity, identify potential issues, and even make necessary adjustments. Voila! Now onto the packet tracer tutorial. Hello everyone. Today I'll be showing you how to perform a simple configuration of router and a stick for Inter-VLAN routing on Packet Tracer. Since I already have everything set up physically, I'm still going to explain first on what you need to do. The first step is to simply physically add a router, switch, and PCs into our topology, as shown here, the one that I made. And basically, well, you can start by renaming our router and switch, which I've already done here, R1 and S1. And I didn't rename the PCs because they already have PC0, PC1, PC2. And after we name our router and switch and we add everything on here, we could start using the connections and do copper straight through cable. We can connect through each one, like I did gigabit 0/0/0 here and 1. And then for each of these, we're going to do the fast Ethernet. So basically fast Ethernet 0.1, fast Ethernet 0.2, and fast Ethernet 0.3. And as you noticed, I left notes for each of the PCs before I started actually configuring in for router on a stick. So we can have a glance on what VLANs need to be created and the IP addresses and the default gateways and stuff that need to be assigned for the ports. So first things first, let's go into our PCs. Navigate to PC0. We're going to fill in our information. So 192.168.2. Down. Should here. 32. There you go. We assigned the different PCs. So the next thing that we need to do is to configure our switch, in which we must start creating our VLANs, and then we must assign the VLANs, and lastly we'll define the access ports and trunk ports for a second step. So let's go into switch, VLAN interface, enable, terminal. So basically, once you go into your switch, you just need to go into configure terminal mode by just, first thing you do is type in enable, type in config T, or just do configure terminal. Alright, now, what we must do is look at our notes and see what VLANs are needed to be made. So, that VLAN 10, 20, and 30. I put 30 here as an assumption because this is fast Ethernet 03. So, should be VLAN 30, because I know these two, VLAN 10, VLAN 20, once creating them. So, let's start by typing in our first VLAN. So, type in VLAN 10, that creates VLAN 10. We can exit, so type in exit, type in VLAN 20, that creates VLAN 20, which will create both VLAN 10 and 20. I think VLAN 30 has to do something with the router, so we'll figure that out later if we need to. If I need to go back, I will. Once we created both VLANs on our switch, let's verify that they were created on the switch. So basically, let's get out of config mode and do show VLAN brief. So this is what you type to verify. You see VLAN 10 and VLAN 20 are created successfully, and they are active. But the next step here is we need to assign the ports. As you see here, the ports are not shown because they're not assigned, which will be your next step in configuring the switch. So let's go back into configuration mode by typing in config T. Alright, so now we need to go and do select the interfaces that are connected from the switch to our PC. So since this one's VLAN 10, fast Ethernet 01, we're going to do type in interface fast Ethernet 01. And we could do this, because this is going to assign the access ports fast Ethernet 01 to VLAN 10. So we're going to do switch port access VLAN 10. And then we must set the mode to access ports, so switch port mode access. Whoops. Now I could do the next PC here, which is going to be PC1, fast Ethernet 02. VLAN 20, so interface fast Ethernet 02. For the 10, we're going to type in 20. And then what we could do now is do switch port mode access again. And then I'll exit. Which now we're going to do PC2, so let's do interface 003. We're going to do switch ports. I'm still going to do VLAN 10 just in case, because I'm assuming it's VLAN 30, that's why I wrote the notes down. So let's just do that again. And then the switch port mode access and exit. And let's verify our VLAN configuration here. So VLAN brief. And as you see here, these are the assigned ports: VLAN 10 and VLAN 20. So now, basically, we can see that right here successfully. And the ports and stuff like that. And now what we can do is we need to no shut gigabit Ethernet 0/1. So let's go into big terminal. Set interface 0/1. And then what we need to do is do a no shut command. And then we could do switch port. This is going to be for the trunk ports now. The switch port mode for the router and stuff like that. Because we were doing this to configure the trunk port for the router on the switch, which allows the performance of Inter-VLAN routing. Now we can do that. We can now exit configure and verify running configuration. So let's type in show running config. Let's see everything's assigned here successfully. And then basically now what we could do is save our startup config. So basically copy, run startup config. The third step is to now use .1q encapsulation for our router. Hold on for just a second. Alright, sorry about that. We're back. So now what we need to do is use .1q encapsulation for our router with the configuration of each subinterface. So now let's first go into our router in the command line interface. So here, type in yes. No. Get out of there. Oh my god. Alright, now we can go into config mode and then go into gigabit. There /0. Alright. I don't know why it's not working. Should be 0, that's fine. We're gonna do a no shut. Now let's do the sub interface, which is gonna be for VLAN 10. Basically, interface. Okay. That's gonna be up. So now we're in there. And we're gonna do the .1q encapsulation. Whoops, encapsulation dots. No, we're gonna do 10. Okay, basically what we need to do now is assign the IP addresses, which is going to be default gateway here, ZC here for VLAN 10. That's why we're at the nightstand, because it's useful. Alright, so now let's do 10.1 and then 255, 255, 255, 0. Now let's exit. Now I need the next sub interface, so let's do int. Now that would be up. And that one here we're gonna do 20. Yeah, because that's for VLAN 20. Now we can assign the IP addresses. Whoops, 168. We're at 1, then we can do a subnet mask. That should be right. Yep. We can now exit out. Now we're going to do it for PC2, VLAN 30 here, sub interface. So interface 0.30. We're going to do the encapsulation. .1q10. That's supposed to happen because it's not permitted. This will show you basically the process of everything so far, what we're doing. So now what we're going to do, in this case, we're going to do I think we're going to do shut down. Yeah. Shut down command. And we're going to exit. So, a useful command here that we need to do, because of this instance here and everything, we're going to give it 0.30. out of there, and we can verify a running config. So show config. We successfully did the sub interfaces, the configurations there. Okay, that's good to go. Now we can show our IP routes. You see here, we have them connected here. Sub interfaces and everything like that. We can start showing what will happen with everything. We can look at the assigned IP addresses being connected to the sub interfaces. Once we have verified everything, we can start showing what will happen with the messages of the PCs. To each other. As you can see, they did not work because they will not ping to each other, so let's try that. They failed. See? So as you see here, like I just said there, they don't not ping to each other because we're not done yet with the VLANs. That's why I probably wrote VLAN 30 here. Alright, PC2. I'm thinking we need to change our IP configuration, so let's change that. So it should be 30 then. That's why we're not pinging. So I think we need to change this here. Unless if I'm wrong. No, it should be good. Okay, yeah, I think that's what it should be. Because it's the default gateway here. Let's go into our switch then. Alright, what we need to do now, because we're in a privilege exec mode, let's show our VLANs here. So show VLAN brief. See here, they're created 1020. And assign ports again. Okay, basically now, what we need to do is, if you look closely, you see fast Ethernet 03. We need to create a VLAN within our switch. I'm assuming it's going to be VLAN 30 now, so let's do that. So config terminal, and we're going to go in there, and we're going to create a VLAN 30. This is why they're not pinging to each other. Partially, I'm assuming. Which will create our VLAN 30 now, because we're going to assign fast Ethernet 03 into VLAN 30. We're going to exit out of that, and we're going to do the interface fast Ethernet 03. Should be here once again. And let's do our switch ports access VLAN 30. I'm going to do our switch port mode access command, and we can exit out of that, exit again, go into our privilege exec, and we can verify the VLANs once again by typing in show VLAN brief. And now we have fixed the issue with the assigning of the ports and the creation of the VLANs by creating VLAN 30 and the different fast Ethernets to assign the ports that connected to each PC from the switch for the inter-VLAN routing process. So now what we need to do is go into our router and go into config mode. So basically, you can see here once again that there are 3 connections of each VLAN for VLAN 10, 20, and 30. So we need to go into config mode. Yep, print terminal. And basically what we need to type in now. Okay. We need to basically type in our sub interface for VLAN 30 or yeah. Yep. It's an interface megabit 0.0.30. I'll put it back up again because we shut it down earlier. And basically what we need to do now is fix our encapsulation.1q. Instead of 10 like we did earlier, we're going to do 30. And then we have to fix our IP address again. It should be 192.168.30.1. And then the default subnet mask. Yup. And now we can exit from our config mode. And go into privilege exec. And let's verify our IP route, which is what we need to do because we send the IP addresses there. Alright, now what you can see here is basically the 3 connections of the sub-interfaces. Point 10, point 20, point 30 for the different VLANs, and they're successfully connected directly from their assigned IP addresses for the VLANs. Yep, 10, 20, 30. So that works successfully well. What we can do now is ping each PC. So let's try that out. Shall we? We need to go into command prompt. And let's ping... Actually, let's ping PC0 to PC1. If you see here the IP address 192.168. Now they should work. Let it here download. It's the same thing. I just figured out this is another method. It saves you time. Because it's like it acts as if it's like a ping for each other with the messages that are sent from packets. So basically we're doing the same thing here. So we can do PC2 192.168.30. Whoops. My bad. Ping 192.168. Assuming it should ping. 25% loss. Yeah. And as you see here, it should work. Yeah, they all work. They ping each other, so we can do that here too. See, now it says successful. They all can ping to each other successfully, and basically can now ping each PC once again easily to each other. They're successfully pinging, and the main reason why I'm using this method as a router and stick is because you can easily see in a simulation of pinging each PC, and you can basically see how we have now created a router and a stick Inter-VLAN routing configuration. And before we wrap this up, we should save our configuration in the router and switch. So let's go to each one here, and let's do a copy run start command, which is very important to do. Alright, let's do it here. Copy run starts. Right, now they're both saved. And basically, this concludes my example and configuration of doing a router on a stick tutorial for Inter-VLAN routing. Okay, so now this concludes my entire presentation and packet tracer tutorial for Inter-VLAN routing and router and stick configuration. Once again, thank you for watching and have a good one.